properties. Solids have crystalline properties. So if we go from that building block into the next, well, and again, remember, quartz is the most common mineral on the face of the earth. And here in Marathon County, you have one of the second most common, a feldspar. Let me say, huh? What color is your granite here in Marathon County? Red. The pink in the granite is a feldspar called orthoclase. And it is, again, a very common. The term feldspar really means field rock. So, again, very, very common, second most common mineral found in rocks today. Okay, if we go from this stage to the next building blocks, we've only got one thing left. The rocks of planet Earth. So our building blocks start actually with subatomic particles, which will lead to the chemist, to the elements, to the minerals, and finally to the rocks of planet Earth. And so these are the building blocks of the lithosphere. Now we're going to do something that you did in the 3rd grade and in the 5th grade, but we're going to add a little bit to it. I'll go through and look at how these building blocks undergo change. All rocks began as magma. All rocks begin as magma. Magma is molten or liquid rock. Temperatures of this are between about 800 to about 1400 degrees Celsius. So we start with magma as our base for the rock cycle. If that magma rises to the surface, and in the original Earth, it would bubble to a surface because of density. Once it reaches a surface, we'll toss in a Lucifer's here. Once it reaches a surface, it is classified as lava. So if it's below the Earth's surface, molten material is magma. On the Earth's surface, it is lava. Not all magma comes to the surface. Not all magma comes to the surface. It stays below the ground, it cools off, it solidifies. And we end up with what are referred to as intrusive igneous rocks. Intrusive forming within. Intrusive igneous rocks undergo slow cooling, which produces large crystals. So slow cooling, large crystals. Large, identifiable without a hand lens. Prime example is your granite. Your granite that is in Marathon County formed in all likelihood hundreds if not thousands of feet below the surface. No longer below the surface. What has happened? What has happened? It's no longer below the surface. You can drive out in Marathon County and see granite all over the place. But if it formed 1,000 feet or several thousand feet below the surface, why do we see it now? It's erosion, yeah. Basically, erosion has leveled the playing field. Large intrusive igneous formations. Large intrusive igneous formations referred to as batholiths. So, and large means anything over 40 square miles. One of the largest batholiths in North America are the Sierra Nevada mountains. They run for 400 miles in one direction, over 100 miles in width, and up to in excess of 12,000 feet high. I can't remember precisely how high they are. At least 2 miles high. So that was all formed under the surface. And that has risen to the surface over time. So intrusive igneous masses, large ones are batholiths. We also have small ones, less than, and these are referred to as stocks. These are small intrusive. And two others, those that form vertically are referred to as dikes, and those that form horizontally are sills. These are all intrusive igneous formations. They're all things you see in Wisconsin. They're all things you see here in Marathon County. Wolf River batholith. Ring a bell at all? Nope. East of Marathon County. In the 1970s, this was under study by the Atomic Energy Commission. Not for uranium purposes, but as a depository for radioactive waste. They were looking at the Wolf River batholith because it was a stable geologic feature, and they could bury stuff in it and it would stay in place. The fine folks of Marathon County in central Wisconsin said, not in my backyard. We'll put it in Edgar, but not in the Wolf River batholith. Mm-hmm. Did you have a question? Okay.
Are those two places where there's a small formation?
In what?
Are those a small formation?
There's dikes and sills and stocks, yeah. Yes, sir. Okay, the stock is a mass. Okay, let's backtrack. Sills and dikes are tabular features. They're something that may shoot up like this, something that may shoot across. It's a thin layer, tabular in nature, and it cuts its way across the existing block. A stock literally melts a big 40 square mile region and drops and forms a glob of molten mass in one area. You have tabular-like features. Oh, and there's one other, but we won't get into it. We're running out of time. Okay, that's the stuff on the surface. In the surface. Lava comes out on the surface. Two features form, and only two. You have lava plateaus, and we have the possibility of a cone. Various types of cones. So intrusive features a wide variety of options. Extrusively, basically cones and plateaus. Okay, well this thing's got a little bit filled in. Let's try next one. What? But I've got 25 minutes worth of material.
Well, then you'll have to just take the
Okay, I'm just doing some repeat to make sure we get the magma to the surface. Okay, once the rock is to the surface and it solidifies, we have an extrusive igneous rock. So we had intrusive, now we have extrusive. Extrusive, rapid cooling. Which produces small or no crystals. Also produces rocks that float. Okay, so